The final part of today's lesson is on the control circuits part of the lesson. So we're going to look at LDRs and thermistors in a circuit. It's quite a simple concept once you've got it. You might need to reread the information twice, but it's not hard at all. So we're going to have a quick recap about sharing voltage. What happens to potential difference in series circuits? So if we have a 12-volt battery in a circuit with, say, 2 or more resistors, what happens to those 12 volts? Hopefully you remembered they get shared. So some of the potential difference, some of the volts go to the first thing, some of them go to the second thing. If there was a third thing, some of them will go to that. If there's a fourth thing, some of them will go to that, and so on. How many volts will each thing get? Well, if they're exactly the same, supposing this was 10 ohms and this was 10 ohms, they would both get 6 volts. If they are different, what's going to happen? Well, the one with the higher resistance, is that going to get more or less volts? Well, is it easier or harder to get through something with a high resistance? It's obviously a lot harder to get through this. So do you need more or less energy to get through it? You obviously need more energy. So there are going to be more volts across the 40 ohm resistor and fewer volts across the 20 ohm resistor. How can we work out exactly how many? Well, this resistance is twice this one. So you're going to need twice the amount of energy to get through. So this is going to have 8 volts. This is going to have 4 volts. Usually you can work these things out in your head. It's quite obvious. If it wasn't obvious, it's a very simple ratio problem. Probably simpler than anything you ever have to do in maths. So you just quickly work out a ratio and solve it that way. I'm not going to go into it now because you've done it in maths, and it's usually you don't have to even think that hard. What you need to take away, a higher resistance in a series circuit gets more volts than the smaller one. So let's look at thermistors and LDRs. Supposing we have this circuit, we have a battery in series with a thermistor and a resistor, and then we've just got 2 voltmeters, one to record the potential difference across the thermistor, one to record the potential difference across the resistor. What is going to happen? Well, which one will get more volts? It depends which one has the highest resistance. So there's 2 cases really, aren't there? If it's really hot and if it's really cold. So if it's really hot, what happens to the resistance of the thermistor? The resistance is very low. So if it's really hot, this has a low resistance. Will it get more or less volts? It will get fewer volts. And so then the voltage across it, the potential difference across it will be really small. If it gets really cold, then the resistance of this increases. The resistance gets really high. And what happens to the potential difference across it? It will get really high. So the potential difference across this will change when it's cold and when it's hot. Why do we care about that? Well, supposing we didn't have a voltmeter here, supposing we had a heater here. A heater will only work if the voltage across it is high. So when will the heater work? Will it work if it's hot? Well, that will be silly. We don't want it to work when it's hot, but it wouldn't work, will it? Because it's hot, this resistance is low, there are not many volts across it, so the heater won't work. Supposing it gets really cold, then this resistance gets really high, gets a really high voltage across it. This is now a heater, it will get a high number of volts across it, and the heater will start to work. If you're wondering why they're exactly the same voltage, well, there's 2 reasons really. The easy one is obviously it's a voltmeter that's recording the voltage, so it must be the same. The second reason is when we looked at parallel circuits, we said that the voltage across a parallel circuit is always the same. So the information I've just said is going to be on the screen now. You can pause the video, read through it, and take a note. Importantly, circuits like this, so that should be an S there, circuits like this are sometimes called control circuits because we can use them to control other things, such as a heater. All right, let's look at an LDR circuit. So here we've got a battery in series with a light-dependent resistor and a normal resistor, and again, 2 voltmeters to measure the potential difference across each component. So what's going to happen when it's really bright? When it's really bright, what's the resistance of the LDR? It's really low. So if it's a low resistance, what will the voltage across this be? It will be really low. So would this work and would this turn anything on, or could you use this to power a light? No. Supposing it gets really dark, well, if it gets really dark, this resistance gets really high. If this resistance gets really high, what happens to this voltage? It gets really high, which means if we replace this voltmeter with say a security light or a street light, what would happen? When it gets dark, the voltage gets high, we can turn on a street light. So again, we've shown how we can make a controlled circuit that responds to light, that we can maybe turn on a light or turn off a light. So here is the information I've said summarized. You can read it and take a note. But now you can stop the video and you can answer the final set of questions.